Okay, now we're going to do a slightly different kind of induction problem where we're looking at proving results about divisibility. Here you see a simple example in front of you, and once again I'm going to highlight the main parts of the induction proof so that you will learn the structure. So first thing, we've asked to prove this for all positive integers n. So we're going to first do what we did before, test n equals 1. And we say, okay, this time there's no left hand side or right hand side, but we think, what does it mean when something is divisible by an integer such as 4? It means it's 4 times something. So we say 5 to the 1 plus 3, that's equal to 8. That's 4 times 2, and that's enough to say, therefore true, n equals 1. Then we do exactly what we did before. Assume true for n equals k. And we think about what we're assuming. Assume that 5 to the k plus 3 is 4 times something, where of course m is a positive integer. Again, exactly the same. Prove true for n equals k plus 1, i.e., it's like a little script. We want to show that 5 to the k plus 1 plus 3 is also 4 times an integer, but of course not the same integer. Let's have a look at that. Now, in each of these we want to express this in terms of what we had before. So we realize that 5 to the k plus 1 is just 5 times 5 to the k plus 3. And when we look at this assumption above, we are really assuming that 5 to the k is 4m minus 3. So that's 5 times 4m minus 3 plus 3. That is just 20m minus 15 plus 3. You should check this step to make sure you understand it, because it occurs in almost every one of these proofs. And that is 20m minus 12. And we're very happy to see that that is 4 outside of 5m minus 3. And we know that this is a whole number if m is. So that's our 4p. And that proves this result by induction. So then we can say, therefore, and by now you should know it by heart, if true n equals k, true n equals k plus 1, true n equals 1, therefore, sorry about the squeak, true n equals 2, 3, all positive n. Now, I'm going to highlight again all the things that are mandatory. Test n equals the first value. Assume true n equals k. Prove true n equals k plus 1. What we want to show. Showing it using our assumption, if true, writing a conclusion. All these things mandatory. This is a simple example. I think you should try the first couple on the worksheet in the next slide and maybe come back and have a look at the second example, which will be a little bit more involved.